Alright, so here are the steps to solve area and play regions. We graph it, find the intersections. We plug into, once we find the intersection, which is a value of a and b, we plug into the integral. We calculate the area using the ITD 3, 4, 5. So first problem, the area between x squared and x cubed. And this is a graph of square and x cubed. The area in the middle part is here. So we graph it. We find the intersects. Intersects is when the two functions equals to each other. X squared equals to x cubed will give us a value of 0 and 1, and we plug this into the integral here. The integral from 0 to 1, x squared minus x cubed dx. Using calculator, we'll get the answer 1/12. Number 7. Same way, exactly same way. We graph it first. The graph will be something like this. This is e to the power of x squared, and this one is x plus 2. And the intersects is really hard to get without a calculator, so we can just use one of the math function in calculator. Using the calculus manual to determine the two intersects points of the functions. So the function will be calculator 5 intersects in your calculator, and you will get the value a and b, value for the graph a and b. A and b, right here. All right. And then once we have the a and b, we can use the calculator function math 9, find the integral f2 minus f1. So f2 here will be x plus 2, because x plus 2 is the upper function. So always set up the upper function first, upper first, and then lower second. And then you press a button, enter. 1.3854 will be the answer. Number 12. Two functions, cube root x and square x squared minus 2. The graph will be something like this. This is x squared minus 2, and this is cube root x. So we know the cube root x will be the upper function. Use the same way, we will get the answer 4.2149. 15 is kind of hard because we have three functions. We graph them first. X plus 6, 6 minus x, x squared, and x squared. We need to find the intersects here in order to like integral these two part of areas. So when x squared equals to 6 minus x, we will get the value x equals to 2. Alright, 15. We will have function like, sorry, this is not right. From 0 to 2. We will have x plus 6 minus 6 minus x, and then this value is here, this part. It's a different color. This part, and this part we'll use another integral. Slightly trickier, but not impossible. So okay, here's how we do it. from 2 to 3. How do we know 3 is because when x plus 6 equals to x squared, we will find this point. And then we set up the integral x plus 6 minus x squared, since because x plus 6 is the upper function, this will give us a value of 37 over 6, so around 6.1667. Alright. How many questions left? Oh, we have two more left. Alright, so 17. One second. Alright, here we go. Alright, so 17. Now, sorry. This is very tricky. 17. Number 17. We have two graphs, sine x and cosine x. If you graph it, it'd be something like this. Sine x, cosine x. Their integral. Sorry, it's not very good. And here we have to be careful because, like, the area here is another color. This part, we have the upper function cosine x. Here is cosine x is the upper function. But here we have sine x as upper function. But what we can know is the two areas are exactly the same, so we don't need to differentiate twice, which is good. So 2 times the integral from 0 to pi over 4 cosine x minus sine x, either way works, times dx. Plug this into a calculator, will give you an answer 0.828. Okay. Alright, last question. Let's go back to classroom. I think we have 19, do we? Yes, we do have 19. Alright, so question 19. No. 19. Two functions. Again. X squared minus kx, k squared, and the graph k squared minus x squared. So the graph is like if the question it doesn't say it only say the constant k, so we don't know the value of k, but we do know k squared will be something positive, which will make the graph something like this. And we know if we set this thing equals to other, you'll find this 2 point as 2x squared equals to 2k squared, so x squared equals to k squared. The 2 points here. Okay, The integral will be minus k to k from which one is the upper function? Here, this one is always the upper function. So it's k squared minus x squared. And plug this in, we will get 2k squared minus 2x squared, because k squared minus x squared minus k squared minus this. Sorry, the other way around. Anyway, you see the difference between the two graphs. Dx is equals to the value of 72, as the answer said. So here we need to find the antiderivative of the two function, which is minus 2 minus this is kind of messy. 2k cube minus 2k cube over 3 minus 2k cube plus 2k square over 3. All of this equals to 72. 7k cube over 3 equals to 72. K cube equals to 27. For k would be 3. It's the value of k. However, k could be either positive or negative, because here it won't affect the graph at all. Therefore, the answer is k equals to positive or minus 3. Alright, thank you.